So we're reviewing again how to, starting the recording now, reviewing, you go to Quick Flight Setup, select our airport. Almost all lessons are in Maui. All right, you hit Open Aircraft. Cessna 172, make sure you select that .acp, say Open. Click on X, I'm down on the runway. Hit pause again. Let me just show you one more time. Click on the brakes or press B for brakes. Push in the throttle. Unpause it. I'll start going forward. You want to wait till about close to 80 knots. You're going to lift off. There's your airspeed indicator right on our left here. It's telling us to go up to 80 miles. I'm going to pause it. That's the airspeed indicator there. So there I'm off the ground. That's looking through the cockpit. Notice my artificial horizon indicator is more blue than brown. That tells me I'm climbing. This tells me above sea level. I'm right pretty close to 1,900 feet at this point. We're up in the mountains. So even though it says it's not more than 90, it's like 1,920 feet off of sea level, 1,920 with that mark, you're just a few feet off the ground. And as evidence, look at it. All right. And then to get around this, I'm using the arrow keys on my keyboard. All right. So we talked about these instruments, especially these top ones. And what I would like you to do, we won't have you actually fill out the paperwork right now. Has everybody taken off? And now I'm going to ask you to do something, okay? Raise your hand if you've taken off. Caden, have you taken off? Cooper, have you taken off? Very good. Now, what I want you to do is make a note. Do this a couple times. Observe what's happening here. Again, I've unpaused. I've got my square. I'm going to hit A again. You're going to need to be inside the airplane, so hit W. Well, let's look at level here. Let's climb some altitude. I want you to climb up like this and see what your airspeed's doing and what your altimeter's doing. Every so often hit pause. Look down and go, okay, there's my airspeed. It's a little bit less than 80. I'm gone up to 2,200 feet. Look what my altimeter's doing. And then do the reverse of that. Put it on pause. And then observe what your airspeed do and what did that do. Now, I have a handout perfectly good for school or something if you want to use it. On lesson 1, that asks you to actually draw in these drawings. So you see, nose is pointed down. This is mainly brown. So let's everybody take a couple minutes here and practice that a couple times. See what they see, the relationship between this airspeed and the altimeter. What's happening when we point the plane up, nose up of the airplane, when we point the nose down on the airplane. All right, people. Let's start asking some good questions, okay? Cooper, what does the airspeed do when you point the nose of the airplane down?
It increases.
Excellent. Keyshawn. Hey, Keyshawn. Keyshawn.
Yes.
All right, what happens to your altimeter? You know, how high off the ground happens when you point the nose down? Does the altimeter go up or go down?
Go up.
Think about it. If you're pointing the nose down, is the plane going into the ground or above the ground?
Oh, going down.
Very good. So while the airspeed is going up, the nose of the plane is going down. Okay? Now, when Ty, hey Ty,
Yeah.
all right, if I pull the nose up, clearly the plane's going to be climbing, so it's going to get higher. But what is the airspeed going to do?
Go down.
It's going to go down. Very good. Now, what this shows you, folks, is there's a relationship here between airspeed and altitude. So watch my plane. I'm going to go up. Look what my airspeed starts to do. I'm gaining altitude, but my airspeed's starting to fall, isn't it? If you all look over my plane, and it might be a bit choppy, but if I go, I'm going to keep climbing and climbing, my airspeed keeps draining and draining, but my altitude's getting higher. Then if I point the nose down, airspeed starts climbing. I'm going really fast. I'm losing altitude. Folks, you are trading kinetic energy for potential energy when you point the nose down. Think of what's an example of potential energy. Does anybody have an idea? I'm going to put everybody's hand up. Buddy, can give me an idea of what potential energy is? Come on, guys. We got to know a little bit of potential energy. Think of potential energy as on top of a hill and you're with a bike. At the top of that hill, you can point the nose of the bike down the hill and you'll trade it. The potential hill is the top of the hill. Kinetic energy, so it's potential energy, just that. And kinetic energy is energy of movement. And we learned a long time ago that energy is never created or destroyed. It simply just changes forms. So I want you all to think about this. You have oil in your car, that's chemical energy, oil and gasoline, I should say. Chemical energy, it's converted to heat, which causes pressure inside your pistons that moves the car. When you're on a bike, you're at the top of the hill. You got potential energy due to gravity. The very top of that hill. When you point your nose of your bike down the hill, you'll go faster. But you're not as high up, so you're trading potential energy for kinetic energy. If you ride your bike up a hill, you're doing all this effort, you're generally trading that kinetic energy, you're going to get slower, but you're going to gain potential energy. And it's never 100% back and forth because we always lose some energy due to friction. All right? Any questions about that? All right then. So when we fly an airplane, we're constantly making a trade-off between kinetic energy and potential energy. And think of an airplane. Is altitude kinetic energy or is it potential energy? What do you think altitude would be? Let's say, so what do you think of altitude? Do you think it's more like potential energy or kinetic energy? Very good, Cooper. So excellent. So everybody else, what do you think? Take a guess. You got a 50-50 choice. Is it more like kinetic energy or more like potential energy? on here? I've got another question. I can pull this down. It's kinetic. I would tell you, I think airspeed would be more like kinetic energy. That's the movement. That's energy due to the movement. All right? So energy due to movement would be kinetic. So what would altitude be more like? There you go. Got it? Potential energy. I'm just going with that. It is potential energy. So you're in your airplane. Altitude is potential energy. Airspeed is kinetic energy. You trade them off. Unless you add energy to the system, more fuel, for example. You can't do both. If you keep the throttle the same on the airplane, you can either go higher, right, and you'll lose some airspeed, or you can go lower, point your nose down, and gain airspeed. But you can't do both. All right? Any questions? Any questions on that? What do you think is more dangerous on an airplane? Low and slow or high and fast? And write back to me why you think that's the case. This is going to take a minute or two. I want you to think about it. My stepson just did a cross country today. I was just on the phone with him. Very excited for him. Very proud. And so he's flying his airplane across. He's an Air Force pilot, Air Force officer, I should say, and weapons pilot kind of thing. But then he's also working on a civilian. So that shows you this guy in airplanes all day long wants to just do it more. He just did his cross country. But if you were to ask him, what would you say? Which is more dangerous? And let's assume that the plane is under control. We're not going so fast. You can control the airplane. And I want you to think in terms of energy. We just talked about energy, potential energy and kinetic energy. So which one do you think it is? Come on, guys. Keyshawn, Ohm, Ty. Go ahead and give me a guess. Tell me what you think it is. Let's not just fly the airplane. This will help you fly the plane better if you think about it. So, is it better? Which is more dangerous? Coming in to land an airplane, low and slow, or is it better to be high and fast just flying around? Let's not talk about landing the airplane because that kind of clouds an issue. You're flying. Would you rather be low and slow or high and fast? Yes. If you said low and slow, you're right, it's more dangerous because here's the issue. When you're high and fast, if you have to get higher, you can always point the nose up. You'll lose some airspeed, but you'll get higher. If you're too high up, you're not going fast enough, point the nose down, you'll gain airspeed. When you're low and slow, if suddenly you have to climb, you don't have enough airspeed to get you to climb. So that's why actually taking off and landing are the two things we got to be concerned with. When you fly a plane, it's kind of the strangest feeling, but if there's no shame with this. Come around the land and the landing doesn't go well. So you turn around and fly. It is really hard, I'll say this, to get nervous, and it's really hard not to want to get down on the ground. Weather's bad, you don't like it. When in reality, a lot of times it's better to be up high just so you have these things going in your case. All right? So it's better to be high and fast in an airplane. It gives you more options. You low and slow, if there's a tree up ahead, you won't, and you pull the nose up to avoid the tree, you won't be flying fast enough. We'll get into a little bit more of this during we do lift. All right? Any questions on this? And in fact, try to fly your airplane just to drive this point home. You see the green and then you got white. White means you're flying with flaps. Green means there's no flaps. We haven't talked about flaps. Don't worry about it now. See if you can fly your airplane, slow your airplane down to 40 and see if you can keep it flying. Go ahead and do that now. So if I unpause this, and you have, so I'm going to keep flying. I'm slowly bleeding off airspeed. And the only way I can slow myself down is by gaining altitude, huh? Unless I hit the throttle. I'm getting a lot of altitude. I'm up to 3,000. There's a balloon. If you fly by the balloons, you'll see there's an Easter egg in one of the balloons. What we call a computer surprise. So if you're flying to see if you ever can find a surprise. Still gaining, still flying. I'm trying to get close to 40. And look, the minute I get to 40, I'm falling out of the air. I point the nose down and get my airspeed up if I can get out of this spin. But I'm in a spin. And I'm in trouble. All right, so everybody try that for a minute or two, and then let's go on to the next thing. We're going to learn some new skills on our Now, if you go, I sent you some links last time. Let me pause this. And we're going to go to Fly to Learn. And take you over here. If you go to Educators, oh, that's always nice when it, let's see if we can get it up here. There we go, Educators. Go to Lessons. And now we're going to download Fly to Learn lesson. There we go. Lesson 2. If you can, go ahead and download those lessons. So let me go again and show you what you're looking for. Go to Fly to Learn. Select Educators up here. Then select Lessons. And there you are. All right. Then download Lesson 2. And I'll tell you what, we can also do this. All right, great. So we're going to do this. Upload it on and share it with you on the handouts. All Well, it's still not doing what I want. It's still saying it's web-based. So you're going to have to go there. I'm not getting the PDF like I thought I should get. Well, now it says web PDF. All right, so I see it now. All right, let me go ahead and put it here. Well, let's go to desktop. That would be a good idea, wouldn't it? Come on. Sorry. All right, it's already on there, so if you want the handout there, that's great. And if you could print it, would be great as we go through this. But I'm going to walk you through this next lesson. We're going to look at a really important question I'm going to present to you all. How many people have been to a small airport? Raise your hand if you've been in a small airport. No big airline jets there or anything, just a small little airport. Okay, no one. All right. Anybody been to a big airport? You've been on an airliner. Has anybody been on an airliner? All right, got a couple folks. Excellent. Now, ask yourself this. Do you ever wonder why the runways are so long with a big airliner? Okay? Well, we're going to start over the next few lessons to figure out why. And one thing we're going to look at now is weight versus takeoff distance. And what we're going to do is we're going to change the weight of our airplane. That's the only thing we're going to change. And then we're going to look at takeoff differences. So if you have this form and you can print it out, if you're near a printer, you can print it out. We're going to fill out these tables. And what this will do is tell you exactly how to do this step by step. So we've been talking about, we're going to be talking about the four forces. Today, right now, we're going to talk about weight or gravity, the forces on there. And what you need to do is gravity is mass times gravity. You still have mass. And even in space where there's very little gravity and there's weightlessness, it still has mass. You can't move something a lot bigger than you are simply by pushing it. Okay? Just want you to know that. So gravity, weight is dependent on gravity. Mass is not. Mass is a measure of inertia. I say it's a measure of stubbornness because it is going to change. So I'm putting everybody's hands down. Let me know once you have made the forces be with you. So you have that to work on. If you'd like to work on it, take this another level. This is actually a really good thing if you do science fair at your school. You could do an experiment. So I've got the lesson here. Go ahead and download it. Make sure you've got it. Raise your hand once you've done that. So Cooper's downloaded. Everybody else, come on, raise your hand so we can get going here. Holmes got it. Good. All right, great. Everybody else got it now. Okay, now, when you see on the second page, instead of me showing you, just goes quick flight setup. Remember, we've talked about quick flight. Go to settings, quick flight setup, and starts to show you everything. Well, that's what this is saying. Hey, go select Lowy, the airport, Cessna 175, clear is CAVOK. And that's where you click on this little deal. All right. Then we're going to do data. This is a new thing you have not done yet. You're going to go to settings, data input, output. and then you're going to select this on your airplane. Speed, this column and this column, which by the way is the same thing as graphical and cockpit display. We're going to be able to graph this stuff. And then because I've done this enough time, there's distance traveled, yours is defaulting that, and landing gear vertical forces. So we're going to be able to look at our landing gear and make some decisions on that. All right? Okay. Now, I want you to do that. Everybody get speed, get distance traveled, landing gear force. Make sure you've checked on all these. And again, go into data set right there. So I'm going to show you one more time. Go into settings, data input output, data set, speed, distance traveled, landing gear vertical forces. There it is. And you'll see it right up here. So this is a way for us to immediately be able to see what our airplane and how it's performing. All right? Raise your, everybody's hands down, raise your hands once you're at this stage where you've got this information right there now. Make sure you're pausing your airplane between turns here. So Cooper's got his, waiting on everybody else. Let's go ahead. Let me know when you have that so I can go on. Let me know if you need me to show it to you again. Where do I go after I see data set? Oh, okay, here we go again, guys. I pause this. I go to settings, data input, output. I select, I don't worry about enable internet or desk file. You're not saving it to disk. Under number 3, speed, I click both those. 21, distance traveled. 66, landing gear vertical forces. Does that make sense? Hope so. Then just click X. There you are, and your value will be up there. All right? Raise your hand once you've got it so we can go on, guys. I really would like to practice this lab. Pardon me. All right, great. I've got a couple more here. Let's get it. All right, so now you're going to go up to settings, and I'm recording this. I will post this tonight. After you've gotten that, you're going to go to aircraft, weight and fuel. And we're going to start off just leaving it at 298. This is in all that documents too. Those papers, those lessons have been revised 10 times. All right? Does that make sense? So then, we're going to come back to this in a minute and change it. But right now, we're going to leave it at that, 298. So what I want you to do on that handout is you're going to take off 3 times. Now, what you're going to do is you're going to have to be like a test pilot. You got to fly it the same way every time. So when you go to take off, keep your pointer right underneath that cross. Whatever, if you're going to say, I'm going to make it about this level. Always keep it, say, somewhere right there. But be consistent. I don't even care if you're on the cross here. But make sure when you take off, it's always the same. So It's pausing. I'm gonna go down. On your Mac, on your PC people, you can go all the way down there. You can use your function keys to throttle up. I think it's F4. All right, then you hit B for, but I have a Mac, so I don't remember what the function key is. But I believe it's F4. Then hit B for brakes. And I'm going to show you how we can graph this then. Let's go ahead and hit that. Hit B for brakes or hit P for pause. So I'm going to go down. All right, wise. My throttle's not pushed in for whatever reason. Sometimes my mouse is doing it. All right, here we go. Now there's my throttle. Going down, they have reindeer. There's no such reindeer, by the way, and we always tease them. So I'm going to try to fly this. See how I'm going to keep it right on that X as much as I can. The reason we do that is lift is a matter of two things: airspeed and angle of attack. So I'm just going to keep it at this so I fly consistently. Same throttle, maybe a little bit below. Sooner or later I should take off. Here I am taking off. Now, everybody please watch me right now. I know we're all trying to fly airplanes. But then go to Settings, Quick Flight Setup, go back to Data Input Output, look at Data C. And folks, this is in your paperwork, but watch, look over here. I'm going to turn off all this stuff, but just a couple things. I'm going to keep V true. Distance traveled. You can do it in feet or in meters. And then the landing gear. And what you see on this is if I run this white string over here, my landing gear have a load on them. And we'll show you. It's the weight of the plane. As I take off, you can tell I started to take off, but I didn't completely take off very well, so it's kind of bouncing down the runway. At this point right here, all three landing gear values are 0. I can look right down here to see that they're all 0. At that point, that's where you go up and measure, well, how far did that take you to get to that point? Because we're going to define liftoff then. Well, I'm at 107 miles per hour, right up there. And my distance traveled is 299.1 feet. See if you can do that. This, if you had science fairs or your project, you could really do experiments this way. So that way you can graph what your airplane's doing. And then go and fly it, and I'll let you fly this whole time. Do that 3 times on the table, and you take the averages. Then do it 600 and 900. I should also tell you, folks, while you're doing that, I have one of did Mr. Mauer tell you about the Raspberry Pi Zero? you have a Raspberry Pi 2. They've now come out with a Raspberry Pi Zero. I've already got two of them. They're going to be pretty amazing. In fact, I've just got in the mail. While you do that, I'm going to pull them open here. I think I am. I better get a pair of scissors. Everything on this thing is pretty small. That's the first thing you notice. And the Raspberry Pi Zero itself is tiny. Think your Raspberry Pi about a third of the size of it is. It's about a third of the size of your Raspberry Pi. It's their newest one. Not quite as powerful as yours, but they're only $5. Now the issue is, though, how are you supposed to control this thing? That's my big question. Because there's only one USB port for the mouse and keyboard. Yeah, it's the $5 one. I'm excited, but I'm trying to figure out how am I going to hook up a mouse and keyboard to the Pi Zero. Because there's only one USB, so unless you're going to use a wireless, but then if I use a wireless, that defeats the whole system of it. And if I have to use a powered hub, that's a problem. So I'm kind of curious what we're going to do on this. How are we doing, guys? What have we learned about our airport? Has anybody gotten to 600 pounds? If you look on that paper, you're going to, after you fly 3 times at 298, you're going to go to weight and fuel, and you're going to pull this bar until it's around 600. It doesn't have to be exactly. And then do it at 900 and see how much, see what that does to your takeoff distance. So here's what I'm going to suggest. Go ahead and do look at lesson 2 and answer those questions on there. And that's where we'll pick up next Monday. Okay? I hope you all have a great evening. And I will see you next Monday, okay?